Ericsson Software Technology is the open source company within Ericsson, and I'm heading that one. But let's first go shortly through today's agenda. We have again 3 presentations, one from our side from Ericsson on the evolving the level 3 IPAM provider for the community and beyond. Then we will have a sort of break with snacks and some food, roughly a half an hour break. And then we have a second presentation on sort of building the global scale authorization with SpiceDB and Kubernetes. And after that, we will have a third presentation right after. I mean, there isn't any breaks in between about the deep dive on cloud-native observability. Those are the three items that we have for today. And hopefully we will get everything finished by roughly 8:15. And then the bus that you came with here actually comes and picks you up at 8:30. So 20:30, try to be on time if you want to get back also to Helsinki in an easy way. Then a couple of practicalities still before we start. So if there would be any emergency, so exits are of course the one that we came in, the one here behind the screen, there is one that goes downstairs and then out. But let's hope that we don't need to use them. And then the toilets are on the left side if you need to use those behind these curtains that you see on that side. But then let's do a short introduction. So what is Ericsson? Even though I think quite many of you know us as a company. So we are a company of roughly 100,000 employees, and we are doing quite heavy sort of R&D investments. And our R&D investments, of course, are sort of focused on sort of 5G radio networks, transport networks, what you need for actually these cellular phones to work. But we are not manufacturing these ones, so don't anymore ask, okay, where is Ericsson phone? There isn't the Ericsson phone anywhere, except in a museum. You might find a couple of them, but otherwise we are sort of building networks and building kind of the infrastructure behind it. And of course, lots of it is software these days, and that's why we are also here in that sense. And the site here in Finland, we are roughly 600 employees, and we have been in Finland roughly 100 years, and this is actually one of the largest R&D sites outside Sweden that Ericsson has, and R&D is the main thing that we do here. We have sales and services organization as well for the local customers, but it is a small portion of that kind of the complete site. So most of us who are here today are actually working on R&D. So that's the main sort of butter for us that what we are doing. And kind of if you look at our R&D, so the different areas that we are working on, one of the areas is cybersecurity. So we have people involved in sort of 6G security standardization, building people involved in building some security products for the operators to actually sort of monitor and secure their sort of networks. Then we have sort of an area called control and user plane software, which is more about these sort of 5G core applications that run in the networks for actually providing the sort of telco services. And then of course we have the cloud platform and software side, which is exactly about today's topics as well, because that's the organization that is building our own sort of Kubernetes distribution, or Ericsson favorite Kubernetes distribution, called CCD, or Cloud Container Distribution. And then of course, as a sort of fourth leg, we have this open source company which I'm also heading, so that works on the upstream projects and works with CSE quite heavily, and different projects inside that. But if you look at how the whole R&D center has sort of evolved throughout the years. So if you go way back before 2010, this was actually a site where we were designing even hardware in that sense. But what has sort of happened since then, or during the 2000s, already started at the early 2000s, that the whole sort of R&D has transformed from being a sort of hardware design to actually purely software. And then, of course, with that, we have moved from kind of purpose-built software, embedded software, more into cloud and cloud-native technologies. So that is kind of the trend that we have seen that has happened inside the site, but also otherwise in the industry. And then our sort of open source engagements, because all of us are here for the open source. So if you look at Ericsson as in the CNCF stats, so what we have done is that we have sort of contributed to 115 CNCF projects, and I think that counts a bit more than half of all the CNCF projects that are within the sort of CNCF landscape. So you might find sort of some kind of a contribution from Ericsson on each of those. So of course, some of them are small bug fixes, and what we have found as we are building our own sort of Kubernetes distro, but some of those are bigger features that we are trying, like in the Baremetal provisioning side, where we are actually even driving the whole community and trying to sort of move that into a more production, or it's actually used already in production for our customers, but also for other people to be production grade and embedded project. And then of course, otherwise than sort of the Baremetal provisioning, what we are sort of interested in, as we are a networking company, we have a sort of interest on the most of the networking projects that are within Kubernetes, our service meshes, Multus, other things that actually sort of make the Kubernetes more suitable for the telco use cases as well. And as said, as one of the big areas, what even this site here is doing is security, so that's sort of built into our DNA that we here also contribute on the security side of things. And sort of doing improvements on the security posture of the project, so making them sort of kind of follow the good principles of different things like requirements coming from OpenSSF and SSDF and other sort of those kind of areas. And then of course storage is also one of the key areas, because storage is something that everybody needs. Then shortly about our commitment on the sort of community side. So basically we are quite a bit of things we are doing for the CNCF. So we are kind of organizing KCDs with of course lots of other folks here in the room as well. We are organizing these kind of meetups, not only here in Jorvas, but also more in the Nordic scale as well. So we have hosted meetups also, especially in the Sweden side, but also other places where we have sort of R&D sites. And then of course, project kiosks, you can often find us, or at least in the sort of metal project kiosks, but also other ones. Istio, for example, is another area where we have our people sort of joining in. And then of course, we do sort of the community work within the different projects where we are heavily involved, like the release engineers for cluster API, security leads in Metal Cube, or kind of organizing these project meetups as well, project internal meetups. And finally, but not least, but there is like maintainers on many of the different projects. And then of course, also trying to be sort of good citizens in the CNCF community overall. So we have actually these days one governing board member, myself, and then Vasila from Germany, who is on the top as of today. That was kind of the short intro about Ericsson itself. And then I think we are ready for today's first presentation, unless somebody has some questions. Right, Petteri, please join here on the stage. So one more thing. Come. Just sort of reminding everybody, because we are also in the Nordics countries. So if you are coming to London, keep on London. Remember there is a meetup for the Nordics folks during the event. So try to join us, meet all your colleagues, all the Nordic colleagues who are also attending FIPMA. And yeah, now I'm ready. So Petteri, please.
Obviously, when I tested this earlier, it was working the right way around, but now that you're here, it's all the wrong way around. Yeah, okay, so,
Cannot hear.
testing 1, 2, can you hear me now? Okay, oh, yay. So welcome to my talk. It's from Baremetal to CAPI, evolving metal cubes IPAM provider for the community and beyond. My name is Peppi-lotta. That's me. That's my picture everywhere, GitHub everywhere. So if you ever see that picture, you know that you'll be talking with me. The reason why I'm talking about metal cubes IPAM today is that I got a task, make IPAM a provider for CAPI. This was over a year ago when I started working here at Ericsson as an intern. I come from a background of web development and I had no prior experience with Kubernetes or any projects related to it. In a year, I've gone from a total noob to our team's IPAM expert, and I'm no longer an intern. I'm here today to talk about the history, present and future of Metal Cube IPAM and how it has evolved from a Baremetal component to a more generic feature that found more users than just the Metal Cube community. So, make IPAM a provider for CAPI. I didn't get much more information than this. My job was to figure out what this entails and how to achieve it. So let's start from where I started about a year ago. The other abbreviation in the initial task is CAPI, and it stands for Cluster API. Cluster API is a Kubernetes sub-project focused on providing declarative APIs and tooling to simplify provisioning, upgrading, and operating multiple Kubernetes clusters. Management cluster is a Kubernetes cluster that manages the life cycle of workload clusters and where, for example, the infrastructure providers run. Infrastructure provider is a component responsible for the provisioning of infrastructure resources that are required by the cluster or, for example, a machine. Meetup is one of these infrastructure providers for Cluster API. Meetup project provides components for Baremetal host management with Kubernetes. You can enroll your Baremetal machines, provision operating system images, and then, if you like, deploy Kubernetes clusters to them. And from there, you can, and from there, operating and upgrading your Kubernetes cluster can be handled by Meetup. Moreover, Meetup itself is a Kubernetes application, so it runs on Kubernetes and uses Kubernetes resources and APIs as its interface. So my head was spinning because of this recursion. Kubernetes and Kubernetes felt very weird to me, but the most important concept to grasp from what I just told is that there is a project, CAPI, that provides a way to manage Kubernetes, and you can add more specific functionality on top of it with an infrastructure provider. And for Baremetal, you can use cluster API provider Meetup, aka KEPEN3 for short. KEPEN3 provides multiple components for Baremetal lifecycle management, and one of those components is IPAM. And that's what we're starting to see here now, that what is the connection with CAPI and IPAM. So now I'll talk about the IPAM a bit more. IPAM means IP Address Manager, and it does exactly what it says. It manages static IP addresses, static IP address allocation using Kubernetes resources. Meetup IPAM has 3 custom resource definitions to do this: IP address, IP claim, and IP pool. And it provides an IP pool controller to handle these CRs. IP pool controller watches for IP claims and then resolves them into IP address objects. So why do we need an IPAM, and what are the benefits of it? IPAM can be used as a simple replacement for DHCP. For example, when you're working on environments where that's not allowed. Users can define IP pools that are non-continuous. You might want to be very specific about the IPs, about the few external IPs you have gotten from your network admins, and define those. You can preserve IP allocation when pivoting from one cluster to another. Pivoting is something that can be done with cluster move. IP addresses are automatically attached to the correct KEPEN3 machine data. You might want to be able to predict what machines get what IPs, and you can do it with the IP Address Manager. And you just might want the ease of defining an IP range once and sharing that range across multiple machine deployments. So I'm gonna go into a few of the technical details about how the IPAM works. So you have a pod, IPAM Controller Manager, running that manages the functionality. IP pool can be applied to the cluster with ranges and subnets that you can define. With ranges and subnets, you can define non-continuous pools. The controller is watching for CRs with kind IP claim to be applied to the cluster. Based on the name and namespace of the spec pool field, the controller selects the correct pool and allocates an address for it. Pre-allocations connect an IP claim name and an IP address together. And this way you can make sure that when you're making a claim with a certain name, you will always get the same IP. IP address spec has pools, pool and claim fields that tell what resource it belongs to. So as long as those exist, IP address cannot be deleted. When you delete an IP claim, you also delete the corresponding IP address. IP claims get added when you create the IP address and it has gotten when you create an IP claim and it has gotten its IP address, the IP claim gets added owner references to wherever the IP wherever the IP address is used, and this way you can't remove the IP claim and the IP address chain when they are in use still. So yeah, so because IPAM is a good component and a feature, CAPI eventually adopted it. And the way adopting IPAM into CAPI happened is quite interesting, and it shows how anything can happen in open source. CAPI defined IP address and IP address claim CRDs that are almost the same as what Metal-Cube IPAM has, the IP address and the IP claim. The only differences are minor changes in field names, and so CAPI made the similar CRDs what we have in Metal IPAM, but it divided those into two different projects. So CAPI took the IP claims and IP addresses, and then a new project, the in-cluster IPAM, was created where the IP pools and live. The functionality is exactly similar to Metal-Cube's IP pools, except some changes to owner references and where Metal-Cube has a namespace IP pool, the in-cluster provides a namespace and a cluster-wide IP pool. So, but here you can see a timeline that the Metal-Cube's IPAM was the first that was created. The official release was made on May 2020. Compared this with the cluster API provider in cluster that I just mentioned in the last slide. It had its first release on October 22, and also in October 22, CAPI added the support for IPAM provider. Obviously, when they got their first official provider, they also added the support for it. In June 24, the in-cluster was added as an official provider, and in November 24, Nutanix was also added as an official IPAM provider, and the last little wall there shows that we are not an official provider yet, but hopefully in the near future we'll get a date instead of that little question mark. So what CAPI did by essentially defining the CRDs is that it made the feature more generic. And at first I was thinking it's a bit weird that they essentially duplicated an existing feature instead of contributing to the existing Metal-Cube IPAM. But as I mentioned earlier, CAPI has infrastructure providers, but it also has bootstrap providers and control plane providers. So they clearly wanted to add a new type of provider to their roster, the IPAM provider. So CAPI added IP address objects and IP address claim CRDs that are always deployed, and an optional flag for defining an IPAM provider to handle these. I get that when a generic provider support is the goal, it's probably easier to copy the feature instead of contributing to an existing project. So, and just to mention here, the in-cluster IPAM and its support can mostly be attributed to Jacob Schreckenbrunner, a German-based developer who is connected with Telecom, and the original Metal Cube IPAM was made by Mel Kilmer, affiliated with Ericsson at the time. So, what does it require for Metal Cube IPAM to become a provider for CAPI? Let's look at a few technical details. So once you have a cluster up and running, you can install a CAPI and an infrastructure provider with cluster couple, like this. I have used Metal Cube as an example. So when CAPI added the support for IPAM providers and KEPM3 deploys Metal Cube IPAM as a part of it, the compo creates kind of an awkward situation where when you run this command, you have CAPI deployed with IP address and IP address claim, and then you have Metal Cube also deployed with IP address and IP claim, and you have a pool that can handle the KEPM3 resources only. So when CAPI added the IPAM provider, they made it possible to use this kind of IPAM flag. And here, as an example, their first provider, it will deploy these, and then a pool to handle these CRDs that are in CAPI. Then my next situation. So then we can have this kind of situation where you provide an infrastructure provider like the Metal Cube and an IPAM. So you will have these still the same IP address, IP claim, and pools to handle it. But then you will also have a KEPM3 specific IP address, IP claim, and a pool to handle that. So let's get a reminder of my original task at this point. Make IPAM a provider for CAPI. So basically what I want to achieve is that when you run a command that you initialize with Metal Cube provider, you will only get the CRDs from CAPI and nothing IPAM related from Metal Cube side. And achieve a situation where you can say infrastructure provider Metal Cube, but also use the Metal Cube IPAM, which will then give us the situation where we have CAPI running, KEPM3 running, and an IPAM. And this goal was fairly simple to achieve. Instead of having IPAM controller manager leaving the KEPM3 system namespace, I created a new namespace for the Metal Cube IPAM system. I needed to add a metadata YAML to the project and change a few provider labels. So, and then my second goal was to have the Metal Cube IP pools be able to handle the incoming CAPI IP address claims and copy IP addresses, as well as handling still the resources that it's already handling, so the Metal Cube IP claims and Metal Cube IP addresses. This situation is basically what was seen earlier, but in this case, as you can see, the pool extends to all of the resources, so it's made a bit clearer. To be able to handle all the like these new resources, what I had to do was essentially duplicate all the functions for creating, managing, and updating the IP address, IP claim, and IP pools. This is I needed to duplicate everything because, like I mentioned earlier, the names in the copy CRDs are a bit different than the ones that we're using. So this is basically how it looked. It's a bit small, but essentially you can see everything is the same, but just changing some names, some versions, and stuff like that. So this was quite many line changes, 2,400 to be exact, and that's a quite lot for one PR that I did to make the Metal Cube IPAM into a provider, essentially. So once I've made these changes, we are in the current situation of Metal Cube IPAM. It's kind of upper teenage years. I have made IPAM into a provider, but because the Metal Cube IPAM is still deploying its own IP claims and IP addresses, it's not valid as an official provider yet. CAPI contract states that CAPI IPAM providers should only deploy a pool to handle their CRDs instead of deploying any additional CRDs of your own. So, kind of the situation is also that CAPI and IPAM used to be deployed at once, and older versions are still deployed together always, and newer releases rely on cluster API's IPAM flag. There's a lot of duplicate code in the Metal Cube code base, and but we can't retire our old CRDs yet because they are in use, and that is a part of the reason why we're kind of in this awkward situation. Then there is also that you might be thinking that if the CAPI IPAM and the Metal Cube IPAM are so similar, that why didn't the KEPM3 just move to use the CAPI IPAM altogether? And that's not possible because of a quite a minor, code-wise minor feature, but it is required in KEPM3, and that's pre-allocation based IP reuse. So, like I showed earlier, IPs can be reused, and KEPM3 is heavily relying on this feature, and that's what I'm showing here, that basically the gains outweigh the cons at the moment. Sorry. Yeah, I was talking with the developer of the in-cluster IPAM, and I was asking, like, would they be interested in adopting also this pre-allocation system? And the developer didn't seem very interested because this pre-allocations is very CAPI specific. And also how it's currently done is that you're matching an IP claims name to an IP, and he was saying that usually people randomly generate names instead of having static names, so he didn't see that people would be much using this feature. In summary, I think it's a good thing that CAPI adopted IPAM. It demonstrates well the type of unusual evolution an open source project can have. Metalcube IPAM is a good component, and that's why it got adopted as the base for a whole new provider type in a major project. The adoption forces us to decouple Metalcube IPAM from all other components. It also forces us to critically examine how the reuse of IP addresses should be done, probably not namespace. Maybe we will keep a Metalcube specific IP pool forever, or maybe we can come up with an idea that will get into the in-cluster IPAM. If the future of Metalcube IPAM is retirement, we will know that it lives on as a part of the project that adopted it, and it was all started here. The feature catering to Metalcube, Baremetal use cases found its way to a major project, and who knows what future development that will come from that. Thank you for listening to my talk, and if you're interested to learn more about IPAM or Metalcube in general, visit the metalcube.io webpage and the Metalcube GitHub. Thank you. Yeah, we have that box thing.
Some questions? I guess not. Sorry.
Let's see if it works.
Almost, yeah.
Yes, thank you for the presentation. I was wondering, could you go to your CRD definition? There was two subnet, basically /25 and /26. So, if I was just wondering how the IP address are allocated. Yeah, exactly.
Yeah.
There was this subnet like /26 and the other subnet is /25. So, how does it really? Can you also control like from which pool I can get the IP address from?
I think it's just going like in order. So basically going from smallest to largest. It's I think it's the same with the subnets. Like it goes through one and then goes to the next one.
Thanks.
Questions?
So if there are no more questions, I'll be staying here, and you can come ask me personally anything also. So again, thank you for listening and have a good event.
Thanks, Peppi. Next is the short sort of networking and food break. So that's served where you came in. So there are tables, there's kind of standing tables where you can pick up some salads and treats and other things. So let's go there, and then in about a bit more than half an hour, we will continue. So right around 7 o'clock, try to be back here. then we will continue the talk.
So first, I'm so glad my USB connector worked. I have a MacBook. It's a 50% chance of working. I was at a meetup in Frankfurt, I think, a month ago. In the meetup room, there were like 3 connectors, none of them worked. So then I used another guy's laptop for the demo. It was a German keyboard, and at some point I had to be like, hey, where is the Z button? I just can't find it. So luckily I'm using my laptop. A bit about me. My name is Sohan. I'm based in Amsterdam. So I flew in here for this because I love talking at local dev meetups and communities. I've been in the industry more than 15 years now. Been with a couple of startups, also spent a lot of time at Amazon, including at AWS. So have a lot of experience in the cloud. And I work for a company called AuthZed. So today I'll talk about authorization. Right? And just to set context, because in the industry people conflate the terms authentication and authorization together, I'll just set context about the two. Authentication is identity, who you are. You know, so things like login and Okta and Microsoft LDAP, all of that. Authorization is permissions, so what you can do. You know, and that's the bit I will be talking about. I'll try and keep this light, so I want to start with a quiz question. I must warn you, if you answer this question, you might be an old person, right? So I'm just putting it out there. Does anyone remember or know what this is? Shout it out if you do. Again, you might reveal your age, so I get that it can be sensitive. Anyone? Yeah, okay, yeah, Google Circles. I think officially, if I'm not mistaken, it was called Google Plus. Colloquially, it was called Google Circles. Some of the younger people in the audience are like, what, I've never seen this before, this is not TikTok. But essentially, this was Google's attempt at a social network, right? Where their idea was, look, Facebook, everyone sees everything. We will have circles where you have like university friends and family, and you can share things separately. This went out of fashion in a few months, like no one used it. But what came out of it was Google sort of re-architected how they did their authorization behind the scenes. Because if anyone has sent an email in Gmail with a Google Docs link, have you seen this form? And if you think about it, this is kind of magic because Gmail is a different app, Google Docs is a different app. But I can, send a document and it says, hey, have you given permissions to this person? And this is possible because Google centralized their authorization. I think they realized that they have all of these different apps like Photos and YouTube and Docs and Gmail, so they could centralize their authorization. And that internal authorization system was called Google Zanzibar. So I think for the point of today's talk, I'll mainly discuss how Google Zanzibar works and how you potentially could use a system like that. Now the good news is Google Zanzibar worked, and in 2019, they released a white paper, confusingly also titled Google Zanzibar, Google, where they actually detailed in pretty high detail how this internal system works and how they built it for scale. If you have the time, I actually suggest reading this paper. It's only 12 pages long. It's written in very conversational English, so it's not very academic, so you can actually just read it during a break. And they listed 5 requirements. Remember, we're talking at Google scale here. So they said it has to be correct. If you have something writing permissions, you can't go wrong. You have to be correct. It also has to be flexible, because again, we're talking about Gmail and Photos and YouTube. All of these are very different applications. So really, it has to be able to model these different applications. At the same time, you need the performance aspects of really low latency. Because any document that's open, you need a permission check, and then you open the document, right? So, very low latency. And you need to be highly available. This can't go down at any point in time, because then everything goes down with it. And of course, you need Google scale. So you need planet level scale. And if you've done distributed systems, you will know that global scale is not an easy problem. Luckily for us, Google have actually told us how exactly they did this, right? And just to give you some statistics, for me, the best part about this paper is the first word, right? It says consistent global authorization system. If anyone here has worked on distributed systems and databases, you'll know that consistency is a very hard problem. Right? Does everyone know what consistency is when we talk about databases? Yeah, most here. Just to set context, it's when a system reflects the state of reality. So say there's an update made to a database, that update should propagate to all the databases across the world, so that when someone queries for that update, you get something new. And imagine that on a global scale. In 2019, they actually said that 95 percentile of requests were serviced under 10 milliseconds, which is very impressive. I'm sure that number has gone up by now. And at the same time, this system could handle more than 10 million client queries per second. Again, I'm sure that number has gone up by now. The good thing is, for the people in Google who are platform engineers and developers, this was just an API. So this was system architected, and they could just call an API and build it into their apps. And I'll talk about that. And this popularized something called reback. So I'll rewind a little bit now to talk a little bit about the history of access control. The most common one is something called role-based access control, or RBAC. Now, I'm sure you'll work in companies where you're assigned a role, like software engineer or sales, and each role has a bunch of permissions. So software engineers can check in code, but can't access quarterly reports. At the same time, a salesperson can access reports, cannot check in code. So that is a role-based access control. Works well for simple things, at scale. Hey, what if you have an amazing sales guy who wants to check in code? What do you do? So it can get a little complicated. Things evolved a little bit to something called attribute-based access control, or ABAC, where any decision was made based on attributes. So for instance, if I had to enter this room in Ericsson, it would be like name, Sohan, time, 6 p.m., role, whatever, and it would check all these different attributes, and there would be a decision point which would say, okay, all of these attributes are fine, this person can enter the room. Right? So it's attribute-based access control. In the Zanzibar paper, Google, and this system existed before, but it popularized it, they introduced something called relationship-based access control, where everything is expressed as a relationship between one thing and another. So what are those things, and how does it look? Now, I made this example trying to manifest me speaking at KubeCon. It's not worked so far, but one day it might happen. But essentially, I'm drawing a relationship between me and a conference. So I'm saying person Sohan is a speaker at this conference. And at this conference, there is a speaker dinner. So in a way, there is a relationship between me and attending the speaker dinner. Anyone here attending KubeCon this year in London? Few of y'all? Yeah? Okay, so say one of y'all, you're an attendee only. You have a relationship to the conference, but there's no direct relationship necessarily to the speaker dinner. Right? So that's essentially what the idea behind reback was. The things you could do relationships between are users like this, and in Google, if you have a Google account anywhere, anytime, you probably have an ID like this, which is called their Gaia ID, and any object. You can have a folder, a doc, a video. So these are different objects between which you can have relations. And a relation could be anything. It could be a member of a group, a reader of a document, an editor of a document, an uploader of a video, whatever. Yeah? So you have users, you have objects, you have the relationship between them. You have to now represent that using something called a relation tuple. Yeah? So this is how you read this relation tuple. You start with the hash and you go to the right of it. So you say user ID 3 is the owner of document 123. Yeah? These relation tuples are fairly flexible because you can have objects relate to other objects. You can have objects relate to other objects relations as well. So in this group, you have the security group is a member of the group engineering. Now this provides that flexibility because say in a company like Google, suddenly security group has to change to the group platform engineers. And in role-based and access-based control, that can get complicated. But here it's just about changing a tuple and then running the system again, and everything is sort of works. And if the syntax is confusing, please let Google know it wasn't me. So we have objects, we have users, we have relations. What are we actually doing here? The idea is you represent all of these relations in a directed acyclic graph. And in computer science, evaluating things like graphs and trees and nodes is quick, and it's an easy way to also evaluate this. So let's go through this. We have a document called some document, and we have on top a reader, right? So we have Fred and Sean, who are only readers of the document. In the middle, we have the owner of the document, which is Jill. Now you'll see a dotted arrow between reader and owner. So there is a relationship or a path from the document to Jill. Similarly, the document has an organization. So the relation could be this document exists or is owned by this organization. This is the name of the organization, and there's an admin who is Hannah. Again, every admin owns a document, and again, we know an owner is related to a reader. So this is exactly how these relations are represented in the Zanzibar paper. And once you have this, the Zanzibar paper defines an API. Right? Again, for us as devs or DevOps people, we just need this API. And with that API, you can write and update relationships, you can delete relationships, you can watch for changes. Someone is promoted from a reader to an editor, so you can watch that change happen. And you can also check for permissions. Does this person have access? Does this person allow to do XYZ? And so on. I'll get to that in detail shortly. So I'll give you an example, right? So we have, this is a permission check where we check if Jill is a reader of a document. You can start all the way at the top, and we say reader, there's Fred and Sean, no Jill, so no dice there. And then we can go to the second one, owner, and say, okay, Jill is an owner, and there is a path between reader and owner, and hence Jill can actually read the document. Right? So this is how a graph is traversed in the Zanzibar paper. Now, this paper also describes something called the new enemy problem. And in older authorization systems, or sometimes if you're building your own authorization system, that system can fall prey to this new enemy problem. So we have Lex, who's an evil person, and we have Kara, who is not an evil person. So what happens is Kara removes Lex's permissions to read a document, and then makes changes to that document. Lex attempts to read it immediately after, but it's not been updated, right? It's a stale check in the access control list, so Lex is able to access this secret plan. So the paper describes this and calls this the new enemy problem. So how do you solve something like this? Well, the paper introduces this concept called a Zuki. We assume it stands for Zanzibar cookies, they don't specify, but let's assume it does, where everything is associated with a specific point in time. So if you make a write relationship to the database, you send a Zuki along, which has a timestamp, so you know when that new relationship was written. And anytime a change in data is made, you can actually add a Zuki to it as well. Going back to this example, right? Suppose T2 doesn't happen. Say Kara doesn't add new secrets. It wouldn't be the worst thing in the world if T3, if this guy tries to read the document and he's able to. Because the document hasn't changed and he had access before. So when you add a new secret, you should also add a Zuki along and then use that Zuki as a timestamp to check for access controls. So that's essentially what the Google Zanzibar paper added in. And the interesting thing about this is not only did it solve the new enemy problem, it also introduced a way to improve latency for your requests. Because say your request doesn't need to be super fresh. You don't need to, it's not as critical to like, give me the last cache data. You can actually specify in the API saying, I don't need something as fresh. So give me cache data with the Zuki, and it'll give you something faster rather than the latest. Or maybe it is critical and you say, I want something that is updated to now. That will increase your latency, but it gives you more security. So it gives you the option of specifying when you want a request. To give you an example, say an access control list is updated and the Zuki is issued. There is a time until which these updates are replicated globally. Again, we're talking about global scale. When you make the request to the Zuki, any of this time is a valid timestamp, right? This includes a timestamp in the future. which will give you as fresh data as possible. All right, so the question I get asked is, surely this doesn't scale like Google scale. How does it work? It looks pretty complicated. Well, the thing is it actually does, and I think it does so because of two strategies. One is aggressively breaking each of these things into sub-problems, and two is aggressively caching as much as possible. Right? So let's take a look at least the sub-problems one. So we're doing the same check. Right? I've written the number 6 there because it's a little more prod specific, I'd say, where Jill's user ID is 6, so remember that. Now, this essentially is a union of 3 checks. We have to check reader, owner, and organization. So first we check reader, Jill is not there, so we go ahead. Next we check owner, Jill is indeed there, and then we can check this last bit about admin as well. How this essentially works is 2 things. One, as soon as there is a yes, it doesn't check the rest of the graph, right? So you're breaking it down immediately. 2, when we're traversing this, we know Jill is an owner, and that relation is stored in the cache. So next time someone asks, is Jill an owner, we already have the answer. Yeah? So that is how there's aggressive breaking down of sub-problems and of caching. All right, so I hope you got a rough idea of how Zanzibar works. Now, in 2019, this paper was released, and it made waves in the security and authorization space, because everyone was like, whoa, this is kind of amazing. So companies started implementing their own, so Airbnb and Carta, they wrote their own implementations of this paper. People started writing open source ones as well, and I think these 4 are the ones that exist right now that are active implementations of Zanzibar that are open source. AuthZed helps maintain SpiceDB and was written by the co-founders of SpiceDB. So I'll talk about that, of course. But there's also Ori, there's OpenFGA, and there's Permify. All of these are implementations of the Zanzibar protocol. There are a few other players in the authorization space that are Zanzibar-like, where they've taken some concepts of Zanzibar, but these are the ones that are probably a bit more faithful to the original. I'll give you a brief about SpiceDB. Completely open source, started by 3 people who incidentally started Quay, if anyone's used the Docker registry Quay, container registry Quay. Started by the same 3 people, but it's evolved to a fairly active project now with contributions from people from Red Hat and Reddit and Netflix, whose logo is not here, and a bunch of other companies as well. So check it out. So the one thing is, Google has this lineage of releasing either open source things or white papers where they describe a problem that they solve for Google. And people have written open source implementations based on what would work for the rest of the world. I think Kubernetes is a great example, but also things like how etcd was actually out of like this old paper called Shoddy, if anyone remembers that. Or Prometheus also was sort of based on like the Google white paper and so on.
gRPC as well.
Yeah, gRPC as well. So there is this lineage of all of these things that companies like Google release, and someone writes an open source implementation so that the rest of the world can use it. And Zanzibar and SpiceDB is no different, right? So Zanzibar does all of this, but SpiceDB adds a layer of, like a reverse index API. For instance, if I go back to this here, at least in the original Zanzibar paper, I can't ask, give me the documents Jill can read, where it goes backwards. But with SpiceDB, that has been added, with, of course, some other features such as developer experience and all of that. So what is SpiceDB, though? It's a database, right? But it's not a general purpose database, so you can't use it for typically RDBMS type things. It's a highly parallel graph database, and you have to use it with an underlying data store, because that's where you store your relation tuples that I showed you. And there is a gRPC and HTTP API to check for permissions, to write new relationships, and to also read and write schema, which basically is how you model a user system. Right? So I showed you the typical Google Docs example of document, read and write. You can model these systems using schema, and I'll show you a demo now, with things, operators like having unions and intersections, etc. So I'll quickly maybe show you a demo. This is a SpiceDB playground. So if I was modeling something like Google Docs, I would say, okay, we have a user here, definition user, definition document, and we describe the relation between the document and the user. So a user can be a writer, a user can be a reader, right? We can even add one saying relation commenter is also user. So we're adding another relation. And you can have permissions. So only a writer can edit, but a reader and writer can view. So over here we would typically add commenter as well. Yeah. And we can add a permission saying who can comment. So that would probably be like a writer plus a commenter, right? So this is typically how you take a real world system and you model it using schema. And then you can add relations into it. I'll maybe just remove this bit for now to keep things easier. Yeah, you can add relations into them. So this is the tuple relations that I was talking about. Line 1, we have first doc, writer, user is Tom. Same document reader is Fred. And Tom is also a reader of the second document, right? So we are writing these relations into a database. So once we have written that, well, oops. What happens? Once you've written that, what happens? Essentially, SpiceDB is a sort of gRPC service that looks into the data store for things like permission checks. So you can check for permissions, and a request is validated if it's correctly formed. And essentially, how SpiceDB works is there are, again, this is described in the Zanzibar paper. There are like SpiceDB nodes running in, and it's passed off to instances of SpiceDB that will actually handle it. Right? So here, I'm just going to open the terminal. I can read the schema this way. This is my current schema. So I can do a permission check. Right? So I say document is first doc, and we will look for read permissions if user Tom has it. Right? Oh, it's not read, it is view, I think.
Oh, you removed it.
Oh, I removed it. yeah, of course. Yeah, this always happens. So say edit is writer, view is writer plus reader. Okay, there we go. Hopefully this should work. I have screwed this up completely.
No, view. Yeah, like in the terminal.
Oh yeah, there we go. Thanks, Lucas. Yeah, so it's true, and I'll show you add an explain flag. So this is essentially how the check works. We can also do like a reverse one to see, we can take like a user like Tom and say what documents Tom has access to. So we say something like Z permission, look up resources, and we say document, view, user is Tom, right? Oh my God. Yeah, so this is the reverse lookup API, right? So, and this essentially is what SpiceDB is doing for you. Of course, this is using my local memory as the data store and not an actual data store. So, and basically, SpiceDB was built keeping cloud native and Kubernetes principles in mind. So essentially, you can create clusters, and it's completely self-discovering. And how, again, this caching works is using a hash ring, right? Again, described in the paper, where not every instance of SpiceDB has the entire cache, because that could be very large, it could be slow. But every time a request comes through, it looks at a hash. So specific nodes have specific caches that it's passed on to. And all of them read from the same data store. And again, there's also a SpiceDB operator, which, as you know, it works like a typical operator. So it does things like upgrade the database or take care of, having no downtime when you're actually upgrading the database. And you can scale, global scale. That's what Google really promised with it. So as you can see here, there are two permission systems, each running in their own namespace. I know they're called Pied Piper and Huli running on AWS, which is a bit of an in-joke, but you can actually run it worldwide, And you can see this is running on the East Coast, that's in the US. You have failovers. And a typical architecture, if you're running it on EKS, looks like this, where you have a VPC, you have a load balancer, and essentially you have an Amazon EKS cluster here with different nodes running SpiceDB. Of course, you have things like a cert manager for TLS certificates and handshakes. And here I'm using an Amazon RDS instance. The typical recommendation is using Postgres as a data store for single region, but if you really want multi-region, you probably want to use something like CockroachDB. Yeah. So that's that. I'm going to show you a very, very quick demo. I think I have the time. Yeah. Of how this would look in real life, right? And I'm basically looking at a Vercel admin dashboard template. Now this is a Vercel template. You don't have to worry too much about it. But basically here, anyone can delete all of this, right? All of these things. So essentially what I've done is I've made it such that only if there is a relation or only if there's permission for the user to delete a product, will the delete button show up. So in a way, I'm combining how permissions works behind the scene with how a UI is actually displayed. So let me just run my app. I'm going to run SpiceDB. So I'm running it locally. I have the binary, so I'm just running it locally. This is SpiceDB that's actually running. And I will just run my app here. Okay, so this is my app. This is localhost. Yeah. Again, yeah. Oops, sorry, I'm just going to run that again. Yeah, all right. So essentially what I've done is I've written a permission or a relation between the logged in user and the product with user ID 1. So this shows the delete button because there is admin permissions, but the other products don't show the delete button, yeah, because there is an existing relation there. I'll very quickly show you the code. It's just straight up React code where I have a schema here, and I've said that only an admin can delete. Then I just have the client. I write the schema to SpiceDB here. Again, fairly straightforward TypeScript code. This, for me, is the interesting bit, right? So I'm writing a relationship between a product. Line number 68, object ID is 1. I've hard-coded it. Don't do that in production, of course. But also I've hard-coded a user ID, and I've said that resource is an admin, right? So this user ID is an admin and can delete that product. So I've written that relationship, and then I'm just calling the lookup. Yeah. I'm just calling the same lookup resources API to say which products have the delete permission, right? And it returns just the one product, at which point I just update my React code here. So here it shows the actions button, it shows the edit button, but it makes a check to see if it's deletable or not, and then it updates the UI accordingly, right? And of course, this is one pattern. In production, you don't want this close coupling between your front end and back end, so there's probably a step in between, but typically, this is how a schema is written, a relationship is written, and a check is actually done. So that's that. All right, I think it comes to the main point, is why am I telling you about all of this? Is this even relevant? And I think it is. Has anyone here heard of OWASP? Yeah, most people, I think. Open Worldwide Application Security Project List. This is the first time I've got that right, I think. And so they make a list of critical security risks to web apps. And many, many years ago, number one in that list was authentication. But I think over a period of time, the industry has realized that, look, authentication is vital. So let's give that off to a third party or like an industry standard. And it's dropped down the list. And right now, broken access control is actually on top of that list because we have been seeing so many breaches of late because of access control problems. And app permissions are hard. We all have to do it. And as our apps become more globally scaling, global scale, and more complex, we'll have to think about ways to actually do authorization. Maybe the Google Zanzibar system is the preferred system for you, but think about how it relates to your software. Anyway, that is the end of my talk. Some next steps, if you want to read about our SpiceDB architecture. It's completely open source. There are good first issues in the GitHub as well, so if you're into that, jump in there. I also do like live streams on YouTube and stuff, so if that's your jam, you can jump in there. And all our engineers hang out in the Discord, I do too. So if you're stuck at any time, no, all questions are valid, so feel free to jump in there. And yeah, thanks for having me. Yeah, hope you learned something new. Do we have time for questions?
I think we have time for it.
Yeah, okay. Who's going to make me close?
So you don't want to have any questions?
No, just throwing. I'm actually pretty good at throwing frisbees.
I'll give you an easy one.
Oh, no. Yeah.
So the Zanzibar paper, or their system is built on top of their spanner architecture, which is like a global SQL.
Yeah.
So what would you recommend? You kind of touched on it, but what would you recommend if someone wanted a global similar kind of architecture for their use case?
Yeah, great question. So I think if you're deployed on Google Cloud, Spanner is the obvious choice. Not everyone is, of course, so then, especially for global scale, for multi-region, the recommended one is using Cockroach database. There are some specificities of how Cockroach work that allows that multi-region deployment where you can achieve this sort of consistency as well. So that's what we recommend. For people deploying single region, I think Postgres is the way to go. You can have read replicas of that data store. So you get the performance with Postgres as well. So you could use like RDS or whatever to do that. So yeah. Any other questions? Yes. Oh. Okay, Lucas, your turn too. Whoa, that's a good catch.
Yeah, thank you for the next talk. It was quite interesting. Yeah, I have a couple of questions actually. One is like, I don't know when this Zanzibar was introduced, but currently open OPA, basically open policy is much in hype or trending this. I don't know.
Yeah.
Is there any difference between like using OpenAPI and Zanzibar way of working?
Yeah.
Which one is better? Have you tested or anything like that?
Yeah, no, that's a great question and it's super valid. And in fact, I got asked this question at the Gothenburg meetup as well. So I think fundamentally, philosophically, they work slightly differently. Right? So OPA is a type of something called a policy engine, where the idea is you're separating your decision making from your code, which is a good thing, which is also the idea behind Zanzibar. The idea with a policy engine is you take this logic like Rego, I think that's what they call their language, which is based on a very powerful language, and you have all of these rules. And anytime a decision has to be made, it basically goes to that engine, and it's evaluated, and then it's done. Now, I think where policy engines work really well is when you have a lot of data that is live and dynamic, right? Like, for instance, in that example with like document and Jill, you can't add things like IP address and time, especially in the way Zanzibar was implemented, because you need to know all these relationships beforehand, right? Of course, with SpiceDB and some of the implementations, they've added ways to do that, but policy engines work really well there, where like say a HTTP packet filter, you have IP address and like headers, you're evaluating all of this info that you get live. So it works really well there. Where it doesn't necessarily work well is when you have very complex scenarios. That Rego and that thing becomes super complex. Like if you go to OPA's own website, they're getting started. Rego example itself is complex for like a very straightforward thing. And in practically, right, say you have a company that's implementing this, there are probably like 2 people who know how that code works, because it's not written in like TypeScript or Python, it's in its own thing. So that becomes like a bottleneck later, right? So it really depends on what your use case is when you're sort of implementing either policy engines or Zanzibar, or even like a standard RBAC system. If it's something simple, that actually works pretty well.
Managing the data you have to do in OPA yourself as well.
Yeah, that too, right? I think what Lucas said is you have to manage the data yourself. The way they write it, they have like the data separate too, so that's another added complexity there as well. So.
Thank you. One more question. So you have this breakdown basically how it works.
Yeah.
I don't know if there was like a owner has like a direct relation, but there is a reader also why there is no direct relation between owner and the relation between.
I thought there was. Like
so
here?
For example,
Yeah, so there is, right? Reader to owner.
So Z is not the reader, like a direct relationship between them.
Exactly.
Instead, there is like a dotted relation.
Yeah, I mean, that's just a way to show it. And the idea is, imagine at scale, you don't want a line from reader to Jill, right? Because then you're just going to have a really, really large number of relations that you're writing. So in this way, any owner that's added later automatically becomes a reader. So then you don't have to add Jill as an owner and a reader. Yeah? So
that
at scale, yeah.
Actually, that makes sense more now. Like when you say like, when you say when the first relation is matched, then it won't check anything. Actually, now it makes sense.
Yeah.
When we have the dotted relation, it will check probably the reader first and
Yes.
find the
Exactly. And in the schema, right, there is this arrow as well. This arrow. So I can add like a subfolder where I say one folder, arrow, another folder, which goes underneath it. So suppose I have all the schema and suddenly I add a new folder, I have to just add that arrow in my schema to say whatever in this folder, subfolder arrow, and the same permissions apply. Same as what happens in your Google Docs. You know, so at scale, these things start becoming easy to operate.
Makes sense. If nobody has a question, I have one more.
Go for it.
So basically, you have like a read and this kind of things, read, write. Those are like, let's say, primitive permission.
Yeah.
So, but in an organization, there could be different kind of permission, right? So, does it also work with some custom made permission, like other than read, write, admin, and
it works in any, like, that's the point of the schema, right? With this schema, I just gave the example because it's easy, but you can look at something like Google IAM, for instance, and this is how Google IAM looks, right? So Google IAM is actually a fork of Zanzibar. So Google Cloud IAM is a fork of Zanzibar. So you can model any system. So think of the system you have at work today. You can model this with schema and with Zanzibar. And that was the idea, right? They could do photos and YouTube and maps and whatever, and model the same thing. Yeah.
Thank you.
I think Jan's looking at his watch, so I think it might be time for me to exit. I'm around here for questions after the event, so feel free, and thanks again for having me.
Thanks, Sohan. And then we have the final talk for today. And it's Petteri about observability.
Okay.
Petteri, which type mic do you want to have?
If you have the headsets available, might be easier.
Okay, everything ready? Good. Hello everyone, and nice to see you all here. My name is Petteri Pulkkinen, and I'm here giving you a presentation about observability. And a little bit about myself. I'm a master level student from Aalto University and studying in CCIS program on my second year there. But let's begin with our topic today. So, what I'm going to talk with you today, we are going to talk about observability. We are going to start with explaining what does observability mean, Then I'm going to explain why do we need observability. Then we are going to go through a simple implementation of it, and then at the second half and bit after that, going through a couple tips how you can enhance your observability layer. And I have been talking about observability, and you see that peculiar O11Y on the slides. So you might be thinking, what's that? So actually, O11Y is just an abbreviation of the very long word observability. So just like with K8S, you just omit the letters and write a number there. I don't know who exactly invented this system, but I guess the mistake has already happened and the world already knows these abbreviations, so we just can't get rid of it. But yeah, that's why we have O11Y. And then, what is observability? Here's just an explanation from Wikipedia, which is, well, can be quite difficult to understand, but what we are actually speaking about, it's about monitoring. We make observations, and based on these observations, we try to determine the state of the system, how it works, does it work, or does it work in the way we are intended to operate it. So in cloud native context, observability can answer to your question, does your cloud native system work as expected? So, okay, we have nice word, nice concept, but why do we need observability? And let's have an example. I think everyone knows how to drive a car, so I guess there are some similarities on driving car or driving cloud native environment. So we all know that the more speed you have, the more you need to observe your environment just to avoid any kind of hazards. And when I took my driving lessons for my driver's license, my teacher reminded me the importance of observing the surroundings. That's pretty obvious because that's their job. But they also tend to say that if you lose the observability of the vehicle, if you don't know where are you going to, you basically you are not the driver anymore. You become a passenger. And if you are just passenger in your car, that means no one is actually driving the car. You are just following the journey to unknown. And if we convert this idea to cloud native environment, do you really want to be just a passenger in your cloud native environment and just let everything go to some direction? Not very nice situation, so let's find a solution how we can improve, how we can regain the visibility and the control. So I'm going to talk about different ways to implement the observability layer, and here as an example I'm going to use a fancy cloud native web service that is running on your cloud native environment. So let's go one step further. How do we implement observability? And let's go it through from the perspective of our web service. So first of all, we have to define our objective. What is the question we want to answer with our observability layer? And in terms of web service, I think the most obvious question is our service running? Is it up and running? Is it receiving requests? And if you are starting your journey with observability, you should just pick some easy question at the beginning, something that makes you the most advantage of knowing. So I think that question, that objective that we chose is a good one to begin with. As a next step, now we know what is the question we want to seek answers. Next, we want to identify the data sources. What can we measure? What can we observe? And if your objective is to observe performance, you can think what metrics can indicate the performance. For example, okay, if we are talking about the web service and we want to answer the question, is there something going on? Do our clients, can they connect to the web service? So we can, for example, just do that. Okay, let's see, is there network activity going on? What is the bandwidth consumption of our application? So, something simple to begin with, and it can be then enhanced later. Okay, then we have measurements, but as a third step, we need to choose how we are going to deliver those measurements to a certain place where we can actually see them, because if we just have a web service running somewhere in the cluster, that might not be super accessible for developers immediately. So for that, we have three very good choices. We have logs, we have metrics, we have traces, and all of these three are widely implemented within CNCF projects. So if you, at the beginning, stick to these three, your life and your journey with observability is going to be much, much easier. But let's take a closer look what these three options are. So first of all, we have log events, and I think that's probably the most traditional way of delivering measurements. It's basically something happens, and then you take the timestamp, combine that with information about the event, and ship that further in the system. And the most important thing here is that log events are usually always related to certain point of time. And nowadays, like previously, log events used to be like textual descriptions about what's going on, but nowadays you can also have structural data related to that. As a second option, we have metrics, and metrics is more lightweight option compared to log events. And the reason behind metrics, why it was developed, was that with log events, it's not super easy to scale up the system, because there's a strong dependency between the exact timestamp and event. So it doesn't scale horizontally very well. And in metrics, we break down this strong dependency, and basically we are doing the measurements next to the application, and then on that level providing an interface for the metrics collection layer to be able to ask what is the current state, what are the most recent measurements you have taken. And this way we lose the exact timestamp, but we can on the other hand decide the resolution on the metrics collection layer. So we are actually not interested in which exact second or in which exact point in time some value changed, but rather than we can find out on a minute scale or a 2-minute scale or 30-second scale when the change happens. And this means that a single data point is not as valuable. It can, like, if something bad happens, it can be lost, and we don't lose the consistency of our system, because we can just continue 30 seconds later, check what's the value, and still receive working time series for further analysis. Then the third option, we have traces, and yeah, let's look the picture we have there. So something has happened, a bird has, or multiple birds have been there. But if you want to find out what exactly happened, how did these footsteps occur in the snow? So we can use traces, which are basically a lightweight solution to record the history, which we can then replay later to further investigate what actually happened in our system. So it's very good for performance analysis and very good for debugging. Yep. Okay, so back to our original question, choosing the delivery. So these are the 3 options, and if we choose any of these 3 options, we will definitely find CNCF projects and other cloud-native stuff that can help us. And for this example, let's choose metrics. I think that's the most easy to begin with, and it's something that is also easy. Yep, let's go with that. Okay, now we have metrics, we have collected data, and we need to visualize it. So we have collected data, and here's our data example. So that's one way to visualize it, but is that very useful? If we think, can we answer to our original question from this table? Is the service up and running? Well, we can see some bytes going up and down, but it's not super straightforward to figure out what is the trend going on there. So we need something better. Okay, here we have 3 options. Basically, all of them are charts from the same data set as we saw previously, but they're made with different techniques. And maybe it would be a good time to activate you as well. So what do you think? Which one of these graphs would best describe the situation, best describe the data, and give the best chance to answer to our original question, like is the service up and running? So who thinks it would be the first chart A? You can raise your hand if you think so. No hands. Okay, yes. What about then chart B? Okay, you're quite good at it. Okay, is there anyone who thinks chart C would be an option? No. Okay. So yeah. So basically, I think you got the point. You just have to visualize it in a way that it's easy to read, something that respects the formal, the naturality of the data. Okay, so now we know the basics of observability. I think you are all familiar with this already. So let's go further. Let's find a couple ways to enhance it. So first option is that let's put our probe closer. Okay, we have so far recorded just the network consumption, but let's implement the probing within our application. So if we can provide the same metrics from the application layer, then we can actually see what's going on there. We don't have to guess what's happening. If we just see network consumption, we don't have to guess, is that originating from the request we are interested about, or is it originating from other activities? The second option is shortening feedback loops. So far we had just a visualization, a chart there, and to be able to consume that, you need to look it up regularly. Okay, one step further could be that, okay, we could program an alarm, yes, but still someone needs to act upon the alarm. So maybe we could also create an autoscaler or other automations related to that. Okay, yeah. Another more technical thing is data quality. So we have our probe set somewhere, we receive data, and as the next step, we want to improve our data quality. But let's imagine we cannot change our probe. We get the data we get, but can we somehow further process the data? So first we need to make a difference between accuracy and precision. So with accuracy, it's basically how close to the real values we get from the measurements. It's like what is the deviation? In accurate data, the deviation between the real value and measured value is small. And then if we have bad accuracy, we can then improve the accuracy by just making more measurements and then taking the average from there. Whilst with precision, we can get a bunch of measurements, but the average is precisely on the value that naturally happens there. And with precision, if our precision is incorrect, or if we don't have good precision with our probe, we just have to calibrate it. Yep. The next one is understanding and controlling the error. So, with binary questions, from the scientific perspective, we can have when we have results, it falls into either of these four categories. So we either have true positive or true negative, which is that our test or sensor probes the situation correctly. But then on the other side, we can have false positive, which means that the result, our test reports is incorrect. It shows positive, whilst in reality the situation is that it didn't happen or it's negative. And then the false negative is the other thing. And now if we are improving our observability, we kind of have to realize that we can't fix both errors. We can't fully get rid of both of them at the same time. So especially if you are beginning with your journey in observability, it makes things easier if you choose which one is the most important to lower and which one doesn't, which one you don't have to care that much. Because if you are trying to minimize the both at the same time, that's going to be quite expensive. So especially, for example, if you are implementing an alert system, do you want that every single possible occasion is alerted to you, which means that you will receive false alerts for sure, but it on the other hand guarantees that you won't miss, or you most probably won't miss a critical alert. Whereas on the other side, if you decide that you don't want to report any alerts without a valid reason, that means that you are most probably going to miss something critical. So that's something that you have to decide based on your case which way you want to do it. But it makes things easier if you choose one, not both. And then, as the last step, it's good to mind that even if you are building your observability layer, you can always improve it, but there's a point after which you might be consuming more resources for your observability than you are consuming for your real service you are observing. So it kind of, you have to remember to keep an eye how much you are consuming, how much time you are consuming, how much resources you are consuming for observability, and try to keep it on an affordable level. Okay, so time to wrap it up. So we can begin our journey by defining the objective. What we are going to, what do we want to seek the answers with our observability layer? Next one, we identified the available data sources for doing that. After that, we chose a delivery mechanism for our observability layer, and then made a visualization. And after that, we had very, very basic observability setup. Then we enhanced our setup with putting the probe closer to the application, and maybe even including that on the application level. After that, we shortened the feedback loops to get more frequent and more faster response times. We improved the quality of the measurements and control the error, the scientific error it can have. And as the last step, we remember ourselves that there's a certain limit how long we can go and afford with this process. So is that the end? Can we do more? Well, sure we can do more, and it's an iterative process. We have to start somewhere, but then develop further the process, and the more we develop, the more we can see, the more we are able to react. But I think at this point, the journey continues, but at least we have implemented some observability. We are not anymore passengers in our cloud native environment. I think we are back on the driver's position. So yeah, thank you. And if you have any questions, I think the catch box is still there.
Somebody's hiding the catch box.
No. There it is.
Well, yeah, I can ask. Yeah. so you have mentioned that mind your consumption. So what is your take on using AI nowadays for analyzing the logs metrics? So do you think that using AI is like a mindful consumption, or is there something we need to still think about it?
I think the main question is that can the AI produce something that answers to your original question? If you can somehow ensure that it produces the results or can refine those metrics, can refine data that is able to answer your question, then it's okay. But if you just ask AI to make a summary without anyone understanding where the data came from, what is about, what is the phenomenon behind that, it's, well, you don't know where does it originate from. It might help you to create some alarm, something that, okay, someone should check this, but it's not guaranteed that there is something, and it's not guaranteed that it spots all the issues in your system. So if you don't have anything else, maybe that's better than nothing, and especially with observability, you should start somewhere. But the further you go from the observability track, the more you have to actually pay attention to your data.
Thanks. Yeah, good
Yep.
answer. Thank you.
I think this is actually super important because I'm from a company who has to use this very extensively.
Mm-hmm.
But how much do you, in your industry, how do you like to use open source, or what exactly have you done in your project or whatever? So what do you suggest? Anything that open source or whatever you have set it up, because it's actually super difficult to develop this good tracing by yourself.
Mm-hmm. Yeah, that's true. And especially like with, if you are talking about tracing, because the tracing has to be implemented on the application layer, it's quite difficult. Okay, there are some approaches that you can inject tracing detection somewhere else, but in my experience, it's much easier if you are using a web framework that does that for you. And I think that's a feature that is coming more widely available, but it's still thing that develops. But the good thing is that if you are basing your infrastructure and especially if you are choosing your delivery models based on the Open Telemetry project or those three things, you will definitely find a CNCF project, an open source project. If you don't find the right project now, there's a very good opportunity that someone else is developing a solution. It's just that if you depend on the commonly agreed standards, you have the best chance to collaborate with each other.
Just addition, I think our company is using third-party providers quite a lot. It's like Step, other companies, so it's really, I would say, very good products that they develop. So, but if you develop this by yourself, it's actually very difficult.
Yeah. Right now, I think one difficulty is that you have to build it up from different pieces. You have to have one piece which integrates that into your software. You have to have one piece that delivers and stores the traces, and then you have to have a third component which visualizes that for you. Okay.
All right. I think we are at the end of the last presentation. It was really good presentations, all three of them. But also, I want to give a hand for all the people organizing this event. So big thanks to everyone who was part of organizing this from the Ericsson side, from the CBRE, from wherever you are, sort of helping on the CACF side as well, Lucas, Kasif and others sort of organizing this. So big thanks to that. And then final reminders, if you didn't catch that in the beginning of the presentation where I showed in London, remember to join the Cloud Native Nordics event that we have on 1st of April in the evening. So if you are participating, if you've got a Cloud Native, come there and see all the other ones who are in the Nordic countries doing sort of participate in the event. And then second one, KCD in May. So come and I know that there are a few sheets still left? I don't know.
Yeah,
Do you have an idea how much we
couple,
have?
10 maybe tickets or a couple, something like that. Yeah.
So be fast, book your ticket. There is still room.
Yes,
So,
yes. So there's going to be 300 people or so, and then we have 40 speakers, 34 talks, and 3 tracks. So prepare for an intensive day at the OP headquarters.
and we have some good names to talk as well, because we have Chris, Annie, well, Lucas, of course, Kasi, Pierre, whoever. So really, try to catch your ticket if you haven't still yet done.
This is taking KubeCon to you instead of you having to talk to.
90 speakers, if somebody wants, just
All right, but there is still some time to do networking before the bus arrives. Bus arrives around 5:30. So until then, let's do some networking and I don't know, Lucas, do you know where the next meetup will be?
No.
So let's stick to the KCD. Let's meet up all there.
Yeah, at least let's meet up there. And if someone has a space that we should have the next meetup in, then let me get in touch with you. Yes, I know. Yeah, but I guess that's.
explain to us.
Yeah. Thank you.